In this module, we'll unpack who can control a managed HSM and who can actually use its keys. You'll see how Azure RBAC and local HSM roles work together to enforce least privilege, separation of duties, and auditable control over high-value cryptographic operations. You've already done the hard groundwork: what HSMs are for, how cryptography and key lifecycles work, and how Azure's HSM options compare. You even provisioned a managed HSM instance. Now we turn to the critical question: who's allowed to administer it, and who can use it for cryptographic operations? Managed HSM usually sits in front of your crown jewels: regulated workloads, payment systems, and highly confidential processes. If someone gets the wrong role, they don't just see data. They can sign, decrypt, or rotate keys, often without leaving obvious traces in applications. So access control here is risk management. Good identity design, least privilege, and strong auditing reduce insider risk, mistakes, and compliance findings, while still keeping operations workable. Managed HSM has two distinct layers of authorization. First, Azure RBAC controls the HSM as a cloud resource. Who can create it, delete it, or change its properties through Azure Resource Manager? Second, once you're inside the HSM, local RBAC controls who can use which keys and perform which cryptographic operations. Microsoft Entra ID supplies the identity, and the combination of operation type, role, and scope determines what's allowed. Think of managed HSM as having two separate doors. The control plane door governs the HSM as an Azure resource. Who can create it, delete it, update settings, or configure networking? That's governed by Azure RBAC. The data plane door governs what happens inside the HSM: creating or importing keys, using them to sign, encrypt, wrap, or restoring from backup. That's governed by Managed HSM Local RBAC, with permissions completely separate from the control plane. Azure RBAC is about managing the HSM as an Azure resource, not about touching the keys inside it. Owner, contributor, and reader roles inherited from a management group, subscription, or resource group define who can deploy, configure, or delete the HSM instance. Even a full owner of the subscription cannot use, create, or rotate keys unless they're also granted HSM-specific access. This lets you separate infrastructure admins from key custodians and avoid concentrating excessive power in one role. Managed HSM Local RBAC governs who can do what inside a specific HSM. Every access decision combines four elements: a principal, a role, a scope, and the allowed actions. The principal is a user, group, service principal, or managed identity. The role, such as key admin or crypto user, defines capabilities. Scope limits where those capabilities apply. Together, they enforce least privilege for managing keys, running cryptographic operations, and accessing audit data. Managed HSM local roles are designed to separate duties so no single person controls everything. The administrator focuses on HSM configuration and local RBAC, not day-to-day key usage. The crypto officer owns key lifecycle tasks like creation, rotation, and deletion. Crypto users or encryption users run the approved cryptographic operations that applications depend on. Auditors review logs, while backup and restore operators protect and recover key material, giving you resilience without broadening access unnecessarily. Treat role assignments like long-term contracts. For people, assign roles to Entra ID groups instead of individual user accounts, so joiners and leavers are handled automatically. For applications and automation, use managed identities or service principals, never a person's credentials. Scope access tightly. Grant access to a specific key, not the whole HSM, whenever you can. Then schedule regular reviews to remove unused, emergency, or overly broad permissions before they become risky. RBAC scope in managed HSM is about balancing control and risk. Use HSM-wide roles only for a small, trusted operations group that truly needs broad authority. Everyone else should be scoped to specific keys, such as a payment key or app signing key, so a compromise only impacts that asset. Separate production, test, and highly sensitive keys, ideally into different HSMs, and document every scope decision so auditors can trace who can do what and why. Picture managed HSM as a building full of locked rooms. A master key opens everything. Least privilege issues a key that opens only the one room someone truly needs. Start with the smallest role that lets a user or app function, then expand access only when justified. Avoid giving applications powerful admin or crypto officer roles. Grant specific crypto permissions like sign only or wrap and unwrap instead. And always pair RBAC with monitoring so suspicious key usage is detected quickly. Separation of duties breaks the end-to-end crypto workflow into distinct, non-overlapping responsibilities. Security admins control who can do what. They don't touch keys or applications. Crypto officers create, rotate, and retire keys, but don't deploy or run workloads. Applications perform only the minimum cryptographic operations they need. Auditors observe everything, change nothing. And finally, a break glass or emergency role exists strictly for controlled, exceptional access. Now imagine your primary admin group is misconfigured and production key operations are about to fail. Break glass access is your safety net. A very small number of hardened accounts are used only to get in, stabilize access, and restore the right roles. Every emergency sign-in is logged, alerted, and fully investigated afterwards. And just like a fire drill, you regularly rehearse this process so people know what to do under real pressure. Access control only helps if you prove it works. Start by listing your key identities: admins, applications, and auditors. Confirm which roles and scopes each one should have. Then run real tasks to confirm what should succeed and what must be blocked. If anything is too permissive or too restrictive, adjust and retest. Repeat these checks after reorganizations, new systems, or incidents, and capture evidence of each review to satisfy auditors and support risk decisions. To wrap up, remember the big ideas. Control plane access manages the HSM resource, while data plane access governs cryptographic operations. Use managed HSM local RBAC with true least privilege, clear separation of duties, emergency break glass paths, and regular reviews. Next, we'll apply this model to key lifecycle management and secure networking.